Alright, so somebody posted this here. The Earth is 4,000 years old. Change my mind. And then somebody responds to it. So the guy posting this is posting the response that it's about the uranium half-life. So the only way we would have apparently gotten lead on our planet is by this uranium decay. So there's some people, well, I kind of mentioned this naturally occurring lead, which apparently doesn't exist because it's not, apparently, I guess, stable enough. But they're still assuming that, I guess, uranium would have to decay on our planet for the lead to exist. But, they're actually assuming something else. Now I've got the good quality microphone, but not the good quality camera. So, my dad predicted that when the James Webb telescope would start looking out into space, they wouldn't just see this red shifting that goes right to where the Big Bang was, but they would see more and more galaxies. And I actually believed him. In fact, I thought, yeah, I actually think that that's what's going to happen. But then I still argued with him because I was also correct about something, and it wasn't about what the James Webb telescope was going to see. It was about what a theory was, because I asked him, what is the Big Bang theory? Well, it's an explosion in space. I told him no. That's what both creationists and evolutionists misunderstand. It's a theory about an explosion of space-time, meaning that we don't have any dimensions of space or time to measure this thing that happens, but our dimensions where we measure things with events with space and time stretches out. And then we have our space and our time within that. So there is no space dimension, a classical space dimension, and there's no classical time dimension to measure this thing, so that it's not an event, because an event happens at a coordinates. It has a center. This thing would not have a center, and it wouldn't be an event. So you could say it's still happening even. So, because there wouldn't be a time, and there wouldn't be a point in space or anything for it to happen. So a lot of scientists, and I'm using the quotations because they think they're so smart, even though he, not even understanding what that was, his intuition alone already proved them wrong, because they were assuming, oh, we're just gonna see like this, there's something happening like it, this, no, you're not gonna see something like that happening. And by the way, when you measure the half-life of uranium in years is literally a measurement of the Earth going around the sun. And if you try to say, well, that's less scientific, years should be measured in what? In what? In a Newtonian sense of time passing, when Einstein already showed that time itself is relative, and that you have to go off the speed of light, which we're already finding out that that's also relative. So you're talking about measuring something based on something that's relative to what would have to be compared to an absolute, and then find out that that absolute is also relative compared to a more absolute, which might not even be an absolute for all we know anyway. So, no. You can't just say, well, these idiots think that the Earth is 4,000. Well, yeah, you could have that same half-life as a classical half-life that we measure now, and the Earth literally have gone around the sun 4,000 times with that same half-life, except that it's basically the rate at which the decay happens itself has shifted enough since then, for all we know, because you have to literally take all that into account. And they weren't taking that into account with their genius theories and assuming that, oh, we're looking this many light years away, and blah, blah, blah. Yeah, and you're measuring it with redshift, no longer with years, because the difference in time and how fast time passes is changed so drastically over that distance. We were talking about classical distances, classical time. Anyone who's using classical distance and time and saying this much time has passed, this is how far away it is, and they use like something like miles or meters or maybe even light. Well, light years isn't going to be the same type of measurement. But those type of people who don't acknowledge that that's really bad to use these Lorentz transformations to have to do things that way. Now, what Einstein figured out is actually pretty simple. It's a new distance formula for space-time. X, Y, and Z are spatial dimensions, classical, and T would be time dimension, classical. And the equation you have is x squared plus y squared plus z squared minus t squared equals a constant distance squared, regardless of your, we should say, point of view, but it's called a reference frame. So you could be going a different speed than me, and your measurements of length and classical time would be different than mine, but when we add them all together in that way, we will both get the exact same distance result, and we both will agree, and we both will be like, yes, we saw that same event exactly the same as each other, even though when I snap my fingers like this, and somebody else looks at it going a certain velocity, they saw this, but maybe at a slightly different contracted length or different time according to their clock that even accounts for light speed. We will still agree because we're measuring not what an instant is, not how many classical time seconds have passed, not how many inches. We're measuring a space-time distance, and that space-time distance will agree according to Einstein. But that doesn't even account for light. That assumes that light is a constant, but that's in its own context. That doesn't mean light is universally constant to the fact that you zoom out the context again, and it has to be somehow magically constant still. No, it still could be a variable. It's just that even when you account for things going 90% the speed of light, and you account for distances from basically one galaxy to a neighboring galaxy, then compared to the speed of light, things like time and space are relative, and they are drastically relative, and the speed of light is essentially constant at those distances. But that doesn't mean that across greater distances or greater periods of time that even your supposed measurement of the speed of light, as we currently are measuring it, would also be constant. That is just some assumption. And so people keep coming up with these assumptions and acting like the Christians are idiots, and they're acting like the people who say, oh, the earth has only been here 4,000 or 6,000 or 8,000 years. They're just complete idiots who have no idea what they're talking about, and they're just completely wrong, and they're just absolutely out of their mind. But it's like, well, do you really understand? Like, weren't you one of the guys who was like, oh, we're going to see the redshift at exactly 13, and then it's going to start, and then with us, the Big Bang, and we get to see how it all formed, and then suddenly you're like, wait, why is there infinitely more galaxies? And then my dad, who's a creationist, is like, yeah, I already told you that there would be more galaxies. Like, doesn't that kind of make you think, like, maybe we were wrong about our assumptions? And yet here I'm sitting as a mathematician telling you, I didn't care if you saw God literally, like, forming things, or if you literally saw anything that you saw, no matter what I said would have been correct anyway, because what I was doing was just explaining math, which is, this is a theory, and this assumes how much stretching there is, just like 1 + 1 = 2. It doesn't matter what you observe about apples. It doesn't matter if I put 3 apples in a bag and let them rot, and then they grow into 2 apples. It doesn't matter. 1 + 1 = 2 is based on axioms of math, and it doesn't matter what the experimental evidence gives, because math is only based on axioms, which are self-evident. So it doesn't even matter what you observe. It's always true no matter what. So the theory being self-consistent doesn't mean that it's applying to real life. So just because you have a theory, that just means that your theory is math, and the math might work with itself, but it might not necessarily match what you see. It could match what you see, but not necessarily as much as you might expect. And that's all I was trying to explain. And I was right about that because I have to be right about that because it's math, so it doesn't matter what you observe. But my dad was actually right about what he expected to observe. And that should mean something to people who just assume that creationists are idiots. And they expected to observe something different than him. And he was right. Like, that should at least mean something. Please. And thank you. I'll see you guys in the next one.